We have a rational function f of x is equal to x squared plus 3x plus 2 divided by x plus 1. And it says what is wrong. So in fact we have here the rational function, but if we see the graph looks is a graph of a linear function. However, if let me take here a pen. So if we factor this function here, what is going to be this function here is going to be f of x is equal. So this is going to be equal. If we factor this one, it's going to be x plus 2 times x plus 1 times x plus 1, and x plus 1 we have in denominator and we have in numerator, so we can simplify this x plus 1. And because we simplify x plus 1, this x plus 1 with x plus 1, the function f of x is going to remain just x plus 2. So we have a graph of the linear function. And what we are doing here, now we are graphing the graph of the function here. The blue one represents the function f of x, that is x plus 2. However, here we have the hole in the graph, because it was this x plus 1 doesn't disappear in everything, even though we have x plus 2. So here remains the hole. It means the graph of the function at this point here is discontinuous. But if you're looking closely here, for example, we take in x plus 1, that's the number what we simplified, and we equate it with 0. And we solve for x, and x is going to be equal to minus 1. So it's minus 1. And if we are taking, I'm sorry here, just let me write minus 1. Is a minus 1. And if we are plugging here f of minus 1 in the graph of the function here in this function, is going to be equal to minus 1 plus 1 plus 2 is going to be equal to 1. So at this point the hole is going to be at the point minus 1 and 1. And this hole here in the graph, if we are looking for the domain is going to be discontinuous at this point, and the domain is from minus infinity to minus 1. So minus 1 is not part of the domain, so that's why we write in parentheses, and is from minus 1 to infinity. And this hole here, we call this function, because it's discontinuous, we can call this one is removable discontinuity, because if we take a point, we can close this hole, and it can be continuous if we take in, for example, x is equal to minus 1, or f of x in fact is equal to 1. If we are writing this as a piecewise function, and if we are taking f of x is equal to the x plus 2 with just different from 1, and here if we take in 1. So if we take in this piecewise function, so we can close this hole, and this function can be continuous. That's why we call this is a removable discontinuity.